So now let's brief circle theorem. So there are some things you need to know about circle. So let's say we have a circle like this. So the center is at the middle. So we have radius. So this is radius. Now from any line you say from center to circumference is radius. So if I have another radius like this, so all these points is what you should note first in circle theorem. If I have another one like this is another radius. Note that radius of circles are always equal. So if this should form a triangle, take note, then this triangle is isosceles triangle, meaning the base angle will be equal. So you will observe that if any triangle, if I have another one like this is another radius. If I have another one like this is another radius. So you can have many radius. So anytime you now have two radius, that's two radii, and it forms a triangle, then the triangle is an isosceles triangle, that is the base will be equal. So another thing you need to know is sum of angle in a triangle is 180. So know the properties of triangle also. Sum of angle in a triangle is 180. So s plus y plus z is also 180. So and anytime a triangle is extended outside, so let's call this place M. So this place x, this place y, and this place z. That means s plus y will be equals to m. Take note. So the exterior angle of a triangle is equal to the sum of the two opposite interior angle. So that means this one will be like s plus y will be equals to m. So if this place is 50, this place is 70. 70 plus 50, 120. So that means this outside will be 120. So the angle here plus the angle here will give you the one outside. So you observe all these things very well. So this is another straight line. Angle on a straight line is 180. 180 minus, that means this place is 60. So if I add all this together, 60 plus 50, 110 plus 70, 180. So that's how the rule works. So now another thing you need to know here in circle is if you have a circle, we already know that this will be the diameter. Any straight line that passes through the center is diameter. And that is also a chord. Diameter is the longest chord. So any other line you see here is a chord. So now a chord usually divides a circle into two segments. So a chord usually divides a circle into two segments. So if this is a chord, so it divides a circle into two segments. Here is minor. Minor means small. So small segments. Why this one is major means big segments. So look at this. So this is minor segments. Why this other one is major, the big one. So you have two segments there. Take note, minor and major. I will be showing you everything if we have question now. So another thing you need to know here is if you have a circle again, if this is the center and you have radius, just know that this place is equal to this place. So anytime you have two radii, then the radii will form an arc. So this is an arc now. So this is an arc. So this is minor arc, meaning small arc. Why this other one outside like this is major. So there are two arcs here, minor and major. Minor is the one you see here. Why this other one like this is major. So there are two, so minor and major arc. So now let's talk about the theorem. So let me talk about one theorem now. So the first theorem I'll discuss is, let me write it, the angle which an arc of a circle subtend at the center is twice the angle the same arc subtend at the circumference. So now many students know this theorem, but they can't identify it in diagram. So now we are going to talk about the theorem and the identification. So let me have this diagram in four different. So like this. Now look at the theorem. The angle which an arc of a circle subtend at the circumference. So circumference is the outside of the circle. So circumference is the outside, the length of this circle. Imagine if you cut this circle here, you can use it to form a straight line. So that length is circumference. So this outside. So now the angle which an arc. So all these circles will have center. So now the angle which an arc of a circle subtend at the center. So to have an arc, so it should be like this. So this is an arc. So let me use, this is one arc now. So this is an arc, from here to here is an arc like this. So the angle which an arc subtend at the center is twice the angle which the same arc subtend at the circumference. So now you will notice that the same arc here that go to the center is the same arc again that go to the circumference. So that is what the rule is saying. The angle which an arc subtend at the center is twice the angle which subtend at the circumference. So if here is 2x, then here will be x. So now the diagram can be in another form. So just know the pattern. So this is an arc. So that is from here to here is an arc AB. Now look at it. The same arc again will go to the circumference. Now look at it. Yes, like this. So see the other one like this. Sorry, it's not to the same. So look at it now. You will notice that this arc from A to B is the one that goes to the center. Is the same arc from A to B that goes to the circumference. So any diagram you see, you have to trace out this law. Angle which the same arc subtend at the circumference, meaning is touching the circumference. See? So that is it. So that means if this place is 2s, this place will be x. So the diagram can be any form. So now the major, this one is a minor arc. So the major arc also can sustain angle at the center. This is minor, small one. So the other one is the major. Major usually sustain angle outside like this. That means from here to here is an arc again, like backward like this is an arc. Then this other small one is an arc. So that big one now makes an angle of this one. If here is 2s, so the circumference will be like this, also like this. So that means this place will be x. So if you have the major one, so just know that that is how it will be. The minor is this one, is the one that always make angle here, and you trace it again to the circumference. But the major is the big one, is the one that always make angle here, and the circumference will be from here and here, so to the circumference will be like this backward. So that means if that place is 2s, then here will be s. So if you look at all this diagram, it's the same thing as angle which an arc sustain at the center is the same, and is twice the angle with the same arc. That means it's not different arc, the same arc sustain at the circumference. So even though this is a diameter, any line that pass through the circle and the center is diameter. Straight line that pass through the center is diameter. If I do it this way, so remember this is straight line, this is 180 degree, then here must be 90 degree, because 180 divided by 2 is 90. So take note of these theorems. So now if I have something like this, if I have center and I have something like this, this is an arc here, AB. So now this arc go to the circumference and come back to this place. Now the law does not hold here, because this same arc that goes to the circumference is not the same arc that come back, it's different arc that come back. So the rules can only hold if you have center that is an arc, and it is the same arc that go to the circumference still come back to that same arc, as in like this. That is when the theorem hold. If here is 2s, here will be x. So now in next video, now let's see question, then we will now trace out the rules.